Bearings. Now, from GCSE, you should remember that bearings have three important facts. These are, one, that they go from north, two, always go clockwise, and three, they always have 3 digits. So, for example, if you had 53 degrees, that's 053 as a bearing. Right, let's look at an example involving bearings. In an orienteering exercise, a cadet leaves the starting point S and walks 15 kilometres on a bearing of 120 degrees to reach A, the first checkpoint. From A, he walks 9 kilometres on a bearing of 240 degrees to the second checkpoint at B. From B, he returns directly to S. Describe the displacement of S from B. So, we want to look at the distance between S and B. It's probably also worth having a go at finding the bearing of B from S as well, because sometimes you can be asked to do that in an exam. Right, so firstly, and most importantly with a bearings question, you need to draw a diagram. So, it says you start at S and walks 15 kilometres on a bearing of 120. So, S, 120 degrees, and it's 15 kilometres he walks. We now go to what happens at A. It says from A he walks 9 kilometres on a bearing of 240 degrees. So, draw another north line, A, 240 degrees, and it says he walks 9 kilometres. So, 9 kilometres, so somewhere down here, to point B, and from B, he says he moves directly to S. So, draw a north line from B, and he's going to go directly back to S. Now, we're asked to find this side here, and as I said, it's also worthwhile finding the bearing of B from S. Now, we need to find a few missing angles here before we can find out our missing side, SB. Now, from GCSE, you should remember for angles in parallel lines, if you look here, you've got a C angle, which is properly called a supplementary angle, and they add up to 180 degrees. So if this one here is 120, this bit must be 60 to make 180. Now, angles around a point add up to 360, so we know two of them, so 60 add 240 is 300, so the last missing bit must be 60 degrees. Now, we've got enough information to find the missing side, SB. Right, we're going to use the cosine rule to do this, and the cosine rule is as follows: a squared equals b squared plus c squared minus 2bc cos a. Now you need to learn this equation, it's not given to you in the exam. Right, so let's label our sides to help us with this question. Right, we're trying to find the missing side A, so our SB is going to be A. Our BC, doesn't matter which way around you do it, let's have the 15 as B and the 9 as C. And our angle A is directly opposite our side, so this one here is A, so 60 degrees. Now we can substitute the values into the equation to find the missing length. So, a squared equals 15 squared plus 9 squared minus 2 times 15 times 9 times cos of 60. And if you figure that out, you will get a squared is equal to 225 plus 81 minus 135. So So a squared is equal to 171. So a is equal to 13.1 kilometres, as all the other lengths are in kilometres. Now that is what it's asked us to do in the question, but I suggested we also find the bearing of B from S. So that means if we look at our diagram, we're going to try and find this bearing. Now to do that, we already know that this top bit is 120 degrees, so we want to find the bit inside the triangle. Now, to do that, instead of using the cosine rule, we're now going to use the sine rule. So, let's relabel our diagram with the new bits of information we've got. Even though my eraser doesn't seem to want to work this morning, so let's just colour over the bits we don't want. So there's A disappeared, there's our C disappeared, there's our A disappeared, and there's our B. Now let's relabel our diagram. So, this time, this bit is going to be A, this one is going to be little a, this one's going to be little b, capital B, and the other one will be little c and capital C. Now, yet again, you will not be given the cosine rule in an exam, so you need to learn this. So, the sine rule, sine of A over A is equal to sine of B over little b. So we need to put in what we know. So let's just look back at our diagram. So A is 9 and the missing angle. So let's put that in. So the first bit is going to be sine of A, because that's what we're trying to find, over 9. And for B, well, B, we're looking at this and this. Now we've just found out what this B is. It was 13.1. So we can now put in those values. So sine of 60 over 13.1. Now ideally you want to be using your exact answer you got from your calculator in the first part of the question. So use the answer button on your calculator to help with this. Right, if we rearrange this equation, we're going to get sine A is equal to 9 times sine 60 over 13.1, which if you figure that out, you get 0.596 ... sine A. Now to remember, to find a missing angle, use the inverse button on your calculator. So sine to the minus 1 of 0.596 is 36.6 degrees. Now that isn't the final answer. Remember that 36.6 is this section between here and here. And we know that this section here is 120. So to find our bearing, the last step would be to do 120 degrees, add on our 36.6 degrees, which makes 156.6 degrees. But remember, bearings can only have 3 digits, so we're going to make this 157 degrees. So our bearing of B from S is 157 degrees.